So here we're going to start with module 2. So in module 1, what you learned was basically uh, ideas about statistics. What is statistics and different types of statistics and things like that. So it's not much quantitative stuff. So there is not much that we can do with module 1, but just to understand what is happening. In module 2 is where your all your content for the exams will start. So module 1 will not have many things that you will be worrying about for the exams. But in module 2, now we need to pay attention to the quantitative stuff, the mathematics stuff. Okay, so let's do that. So here we have, there are different types of data. So when you say data, basically what does that mean? Data means like your name, my name, number 45, number 88, 45 degrees Fahrenheit. These are all data basically. Okay, now we are going to go and use this data in different levels of measurement. Statistics is all about measurement. So we measure certain things and then we'll come out with what we have measured and then use that measurement to come out with what are the things, what are the trends, and what are the answers, and what are the solutions, and things like that. For instance, what I would like to do is this. I will stand outside Roosevelt University, and anybody who's entering the Roosevelt University, I'll ask them, hey, do you love going to Roosevelt University? And I'm getting answer yes or no, and I note down that. That is an observation. Each student's answer is an observation. Okay, so if one student says yes, that is one observation. The second student comes and I ask him the same question and he says yes. The third student comes and she says yes. So I have 3 yeses now. Now I have 3 observations and 3 yeses. That yes is basically this is my measurement. This one here. This is the normal level of my measurement. And that is, now I can say that he or she, which is a gender, it's a nominal level. That male or a female is nominal level. Yes or no is also a nominal level because it is just a text. Okay, how many people said yes, how many people said no, that becomes nominal level. Ordinal level can be ranked. Okay, so I can say that maybe the first student came with an emphatic yes. The second student came with yeah, yes, that kind of a thing. But I don't know what is the basic differences in this emphaticism and this nonchalant kind of a way. So that I don't know, right? And that I cannot say with the ordinal level. So ordinal level can be rank ordered. It can be qualitative or quantitative, but it can be rank ordered, but I wouldn't know how much the differences are in ordinal level. The third level is the interval level. Here it is totally quantitative in the sense when I ask somebody, what is the temperature outside? The person will say 75 degrees Fahrenheit. Now I note down that answer. That is one observation. I ask the second question, the same question. He or she will say 74 degrees Fahrenheit. And now I know that I have 2 answers, 75 degrees, 74 degrees. But then I know one thing for sure. The second student thinks that it is sort of cooler than the first student. I can infer from there. That is the inference that I can get out of this interval level of measurement. Okay. The ratio level has got a 0 point. It's like, for instance, the same thing. The temperature of the room, I can set it to a level which is, the bottom level is 0 and the top level is 120. And now I have something which is 75 degrees. So 75 degrees is in between 0 and 120. And I can say that 75 is something little warmer than the 0 degrees, which is really cold. And it is cooler than the 120 degrees, which is really, really hot. Okay. And one of the things about ratio level is that I can use height, weight, age, salary, all these things. These are totally quantitative stuff. And you can do all the mathematical operations. When I say mathematical operations, this will be plus, minus, division, and multiplication and things like that as well. Okay, that is the mathematical operations. So we found that the ratio level, or whenever we have the quantitative thing, we can do some mathematical operations. So this basically is for multiplication, this is for division, and this is for addition, and this is for subtraction. These are some of the simple mathematical operations that we can do, and we can do some complex ones as well, as this is the power and so on and so forth. Okay, now let's look at what is called frequency distribution. Frequency distribution is that way. So you have some data. This is the data. So this data basically is that I'm having a batting average of player number 1 in Cubs. This is the batting average of player number 2 in Cubs, and so on and so forth. Okay, I cannot make much out of this data. So what I'm going to do is I want to know how players have actually done. What have they achieved? So to do that, one of the ways I can do that is to find out what is a frequency distribution. So I'm going to convert this data to frequency distribution. Okay. And this is a common way of doing it in statistics. How do we convert that? I'm going to make it into multiple bins, and I'm going to count the number of people who have made that into that bin. For instance, one bin is 0 to 0.49. This is my first bin. And I can see that, if I go through this whole thing, if I go through this 0 all the way and then all the way back, there is nobody who has done anything which is less than 0.05 here in this first bin. Okay, and so the number of players is 0. Similarly, there is nobody who has done anything which is 0.099 and less than that. Okay, so there is also 0. Now let's say 0.1 to 149. 0.1 to 149, I have, now this is not it, 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 this is not it. So nobody in the first row, none of the players in the first row has got 0.1 to 0.149. Let's look at it from the second half. In the second row of data, I have from 0 to 0.149, I have one person here. Okay, and then another one I can see is this one. I have 2 persons who have done that and nobody else. So now I can say that the number of players who batted with an average of 0.1 to 0.149, the number of players is 2. So I can do the same thing, so on and so forth, with all the frequency data. Okay. So let's go to the next one. In the next one, basically, I have the frequency distribution for telephone calls made from my cell phone. So what I'm doing is I make calls from my telephone between 9 a.m. and 12 noon in the months of October, November. I'm observing those and I'm measuring those basically. So I'm counting the number of calls that I've made from my cell phone between 9 a.m. and 12 noon in the months of October and November. And I come out with this data. Okay. So once again, guys, let me get this straight. So this is my data, basically. Okay. So I have this data. Now I'm going to count. The number of phone calls that I made by using the same frequency distribution method. So I'm going to convert this into frequency distribution. How I'm going to do that? My lowest number in all this whole thing is actually 0. And I can see the highest is about 19. So I'm going to make it to 20, 0 to 20. 0 to 20 is my range. So in this 0 to 20, I'm going to make about 4 bins. And those 4 bins will be, one is 0 to 4, another one is 5 to 9, another one is 10 to 14, the fourth one is 15 to 20. So let's count. Now let's take this 15 to 20. If I take 15 to 20, there is 1 here. 15 to 20, and 15 to 20, there is 2 here. And those are the only 2 I have, so that's why I have this 2. Let's take 10 to 14. 10 to 14, I don't have anything in my first column. I don't have anything in my second column. In the third column, I have 10, 1, 2, 3. I have 3 numbers which are between 10 to 14. And in my fourth column, I have the fourth one. And in my fifth column, I have 13 and my 10 here. Okay, so I have 6 in my 10 to 14, and therefore I have number of days is 6. So what I've done basically is this. During the months of October and November, I have less number of calls, 0 to 4, for 11 months, for 11 days, and I have 5 to 9 calls per day for about 16 days. So actually I'm not doing bad right now if I look at it. So from this data of gibberish data with nothing, and now I have something data here. Some data here which basically says, well, I'm not that bad actually. I'm making only 5 to 9 calls, which is, for 16 days, majority of the days. I mean, these high number of calls I'm doing only for a very small period of time. So actually I'm doing really well with my cell phone calls, basically. So I can get some inference out of this from the frequency distribution. Let's go to the next idea. The next idea is basically to come out with what is called a relative frequency distribution. The relative frequency distribution, what I'm going to do is to calculate the percentages. How do I calculate the percentages? I already calculated the number of days for the number of calls, right? My total number of days is 35. I have 35. So if I go back here, I have what? 35 data. This is 35 data here. Okay, so I've got this 35 data, and I'm going to go with this is my 35 data. Okay, and I'm going to go to the next one. And in the next one, I'm going to look at the number of days is 35. Now I'm going to do the percentages. How do I calculate the percentages? The first one is going to be this 11 days. So 11 divided by 35. And that comes to 0.31. And that's why it is 31%. For 16, it is going to be 16 by 35. For 6, it is going to be 6 by 35. For 2, it is going to be 2 by 35. And this is roughly equal to 0.06. So that is what it is, 6%. Okay, so now I can calculate the percentages from my frequency distribution. And this is called the relative frequency distribution. Okay, now what I'm going to do is I'm going to go one step further. I'm going to go one step further, and that is going to be to calculate the cumulative frequency. So I've calculated the percentages in my last slide. Now I'm going to go to the cumulative frequency. How do I do that? My cumulative frequency for the first bin, 0 to 4, is going to be strictly the same thing, the 31%. The second cumulative is going to be, I'm going to take this number and I'm going to add it to my second bin number, that is 31 plus 46, and that comes to 77%. The third cumulative for the bins 10 to 14 is going to be actually this 77% plus this 17%. 77 plus 17, and that comes to 94%. Okay, and next thing I'm going to do is the last one is 94 plus 6%, that is 100%. So now I have the cumulative percentage. This is how you calculate the cumulative percentage. So what we have done so far basically is we have assigned the bins from some data using finding out which is the lowest and which is the highest, and then putting it in different bins. And you can make different bins actually. You can make this a 0 to 2. You can make it 0 to 2. The second will be 3 to 4. You can make, instead of 4 bins, you can make 8 bins as well. So, but choose something which is solid. So you can go, I chosen 0 to 4 simply because I just wanted only 4 bins. Okay, so it is easier that way. So go to according